Here we go. 5.3b, logarithmic functions and their graphs. So yesterday we talked about exponentials. Today we're talking about logarithmics. Okay, logs. They go hand in hand. So there are different types of logs. First, we're going to define our common log. So common log is a log function. So it's a log function with base 10. Okay, so when you see common log, it's the one that just says log x. That's common log. 10 is invisible. So if I have a log and there's no base given, that means it's common log and the invisible value is 10. Okay. Next is natural log. Your natural log means that you have a log function with base e. Okay, a log function with base e. So with natural log, it could be written as log base e of x. However, remember, mathematicians are lazy and we don't like to write more than what we have to write. So basically, we condense log base e to become natural log, ln of x. So it went from log base e to ln x. Huh? Okay, so those are our vocabulary that we needed to highlight. Someone who wanted to make the world a better place. All right. Log function. The log function with base A is the inverse function. So we're going to write inverse function of exponential function f of x equals a to the x. What is the purpose of an inverse function? Anyone? Everyone. What is the purpose of an inverse function?
To confuse people.
No.
What is that? So that you know the opposite of x.
Almost, but a good word to use was opposite. Okay, it's the opposite operation, right? An inverse function's job is to undo what you did. Okay, just like the inverse of addition is what? Subtraction. So if I'm trying to solve something, I'm trying to undo what I did. How did I get here, right? So I'm going to do the inverse operation. And so log is the inverse function of exponential. Okay. So the logarithmic function with base e is defined as, we write it as f of x equals log a. It's a subscript x. X is called your argument. Okay, so when you think about it in terms of what we wrote, you're going to have log, you're going to have a base, and you're going to have an argument. Log base argument. Okay. The notation log AX is read as log base A of X. So let's do kind of like a class read aloud. If I wrote log what does it say?
Log base of 2 of x.
There we go. Log base 2 of x, right? What if I wrote there we go. Log base x of 5. Okay. All right. Yes. All right.
Wait, repeat what you said, Marshall.
Log base x of 5. That is how the log is read. Cool. All right. What if you just had
Log base of 2.
log 2? It's just log 2. The reason, or you can say log base of 10 of 2. This is our common log example. Remember, the 10 is invisible. When there is no log, there is a 10 there. So you can just say it as log 2 or log base 10 of 2. Okay. All right. I know it's new and ish. All right, here we go. Next, we have the equation of x equals a to the y in exponential form is equivalent to the equation blank. Okay, I'm going to write it a little bigger to show you how it's working. If you have x equals a to the y, this is an exponential, right? Agree? Why is it an exponential?
Because y is the exponent.
There we go. Y is the exponent. The variable is the power. And when you have a variable as a power, it is an exponential. Do we get it? Got it? All right. So we talked about how log and exponentials are inverses of each other. So that means I can rewrite this as a log. The best way I'm going to tell you to rewrite it, I call it the arrow rule. Okay. All right. Here we go. So the base of my exponential is going to be the base of my log. The base of my exponential is a, and then what it equals is going to be my argument. Okay, it's going to be my argument. So therefore, this is log base a, and my argument is x. What my arrow doesn't go to is what I'm equal to. And what do I equal? Y. All right, let's try it. So I left y'all space so y'all can write down these let's tries. Do we see that? Okay. So we have, let's do 4 equals 2 to the x. So how would I write that as a log?
Log base of 2 x 4 equals x.
There we go. So log base of 2 of 4 equals x. Do we see that? Okay. All right. When you're evaluating logarithms, remember that the algorithm is an exponent. Logarithm is an exponent. That means that the log base a of x is the exponent that you're looking for. It's equaling the exponent that you're looking for. And it's just going to be raised to the x power. So you're asking yourself, so see how we became this? This is saying 2 to what power equals 4. Is that not what it said as an exponent? 2 to what power equals 4?
Yes.
Yeah, it did. Right? So that's what the log is asking you, but without being written as an exponent. 2 to what power is 4? So if I had a log that said log base 3, 27, I'm asking you what?
Power 3 equals 27.
There you go. 3 to what power equals 27? And the answer would be what? Power. 3. There you go. You redeemed yourself, Marshall. There you go. 3, right? 3 to what power equals 27? And that would be 3, right? Here is saying 2 to what power equals 4. And what is that? 2. So my answer would be 2. Okay. All right. So I'm going to pause on that and I'm going to give you 30 seconds to rewrite this as an exponent and evaluate. Yeah.
Oh.
Not that much. All right. So 30 seconds for you to rewrite as an exponent and tell me the answer. What's the answer?
Like what x equals? No idea what that.
There you go. And what is it? You ready?
No.
No.
Where's log? There we go. Oh, I don't know. It's not in the center.
It said to evaluate. All right, good. Good job. Let's see. All right. How do I turn this into an exponent? What is it asking me?
5 to what power equals 1.
So 5 to what power equals 125? So to what power?
3.
3.
Oh, yeah, duh.
Okay, remember the log is asking you 5 to what power equals the argument, right? So in this case, 5 to what power equals 125. Okay, all right, we're going to look at an example where it's harder, where you can't do it, and how we have to result to using a calculator, okay? All right, it's not harder, it's just we can't use it. So here, if we have log base 10 of 300, so we're saying 10 to the what power equals 300. Well, powers of 10, is a power of 10 gonna give me 300? No, 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1,000, okay? So that means that my only option to calculate this is using the calculator to get an approximate value, okay? So in the calculator, notice how this says log base 10. Log base 10 means that I'm using the common log, just log, the common log, okay? And then I would have log 300. So when I go to the calculator, do you see where it says log? I'm going to press 10, hit enter. And what do I get? Oh, not 10. I meant to put in the number. You saw nothing. I'm gonna press log 300 and hit enter. And what do we get?
2.77.
Perfect. So it's approximately 2 and 477,000. Okay. The other way is, notice how it said log base 10. Now let's just say I'm a person who needs to see it how it is. Using our calculator that we have, there's another way of typing it in. With our calculator, to get it where you can change the base, you're going to press second, then you're going to press window, and then you're going to press 5. So if I want to be able to put it and change the base, I have to press, I said second. I didn't mean to write second. Ignore that. It's alpha. It's alpha. I said sorry. I'm sorry. I'm sorry. It's me. Alpha. There we go. So I'm going to press alpha, window, and then you see where it says log base. That means I have a base other than the common log. So I'm going to press 5. In this case, it's still the common log, but you can see I can type in 10. I can type in 300. And I get 2 and okay. All right, now let's say that you don't have our handy dandy calculator with change base. There is another way that you can write this in the calculator. The other way is you're going to write, it's the log of your argument divided by the log of your base. And this you can do on any calculator, okay? So the third and final way is we can do log of 300 divided by log of 10. And guess what? We still get it, right? So if I didn't have a TI-84 at home and I couldn't do alpha window 5, could I still find my approximate answer? Yes, because I can turn any calculator and have a log. Got it? Okay. All right. So this will be our stopping point.